this lecture we find out the area of the circle. In the drawing we have quadrilateral ABCD. Inside this quadrilateral we have this circle. In addition, you know that side AB of the quadrilateral is equal to 2 units, side BC also equals to, side BC equals to 8 units in its length, and side DC also equals to 8 units in its length. This is angle DCB that is equal to 90 degrees. This is angle ABC that is also equals to 90 degrees. Our mission is to find out the area of this circle. So first of all, we'll do a construction. We'll extend side DA and side CB of the quadrilateral until they touch each other. So this is their touching point. We define the touching point as point M. So actually BC or CB is one side of the quadrilateral ABCD. Therefore it is absolutely a straight line. When we extended the straight line CB by a straight line, the result must be a straight line. So CM is the result of the extension. When you extend the straight line by straight line, the result must be a straight line. So CM is a straight line. So if we focus on the upper side of the straight line CM at point B, here the sum of the angles must be equal to 180 degrees according to the rule that the sum of the angles from one side of a straight line is equal to 180 degrees. So which angles we have at the upper side of CM at point B? We have this angle that is equal to 90 degrees plus angle ABM. In total the sum of those two angles must be equal to 180 degrees according to the rule that I mentioned. Therefore the missing angle here must be equal to 90 degrees. Angle ABM must be equal to 90 degrees. In order to complete the sum of the angles from the upper side of CM at point B to 180 degrees, the missing angle here must be equal to 90 degrees. We focus on the right angle AMB. We define angle AMB as theta. So in the right angle AMB, this angle equals to theta according to our definition. This angle equals to 90 degrees. Therefore, the missing angle here must be equal to 90 degrees minus theta. Why? Because 90 degrees minus theta plus theta it is equal to 90 degrees, and 90 degrees plus 90 degrees is equal to 180 degrees. That is the sum of the angles in any triangle. In the next step we focus on the big right triangle DMC. This big right triangle DMC, this angle equals to theta, this angle equals to 90 degrees. Therefore the missing angle here must be equal to 90 degrees minus theta, exactly like this triangle. Okay, triangle A and B. So in the next step, we will prove that the big right triangle MDC is similar to the small triangle A and B. So again, we will prove that the big right triangle TMC is similar to the small right triangle A and B. So why those two right triangles are similar to each other? First of all, those two angles are both equal to 90 degrees, therefore they are equal to each other. So we can write down that angle DCM in the big triangle is equal to this angle ABM in the small triangle, again, angle DCM in the big triangle is equal to angle ABM in the small triangle. They are both equal to 90 degrees, therefore they are equal to each other. In addition, this angle theta is a common angle that belongs to both triangles, so I can write down that angle theta equals to itself. So angle theta equals to angle, call to angle theta two different names. Angle theta is actually angle DMC, and it is equals to himself. Angle theta can be defined also as angle AMB. Let's get again. This equation means that angle theta equals to itself. It's a common angle that belongs to both triangles. And finally, those two angles are both equal to 90 degrees of theta, therefore they are equal to each other. So this is angle CDM in the big triangle. That is equal to this angle, that is actually angle MAB in the small triangle. Repeat again. Angle CDM in the big triangle is equal to angle MAB in the small triangle. They are both equal to 90 degrees minus theta, therefore they are equal to each other. So we actually proved that all the triangles in the big triangle DMC are correspondingly equal to all the triangles in the small triangle AMB. Therefore, we proved that the big triangle DMC is similar. This is the sign of similar to the small triangle A and B. According to angle similarity rule. What is angle similarity rule? Angle similarity rule is that if you prove that all three angles in one triangle are correspondingly equal to all the triangles in another triangle, then they actually proved that the two triangles are similar to each other according to angle similarity rule, exactly as we proved in our two triangles. And from the fact that the two right triangles are similar to each other, we derive that the following relationship exists between their sides. We derive that MC, MC in the big triangle over MB in the small triangle is equal to DC in the big triangle over AB in the small triangle. I'll repeat again. MC over MB equals to CD over AB. What is the length of side MC? From the drawing it is very easy to see. Side MC equals to MB plus BC. That is to say, MC equals to MB plus BC, that is 8, so in total MC equals to MB plus 8. MC is MB plus 8 over MB equals to CD is 8 and AB is 2. So in total CD over AB is equal to 8 over 2. 8 over 2 is 4. So MB plus 8 over MB equals to 4. We multiply this equation by MB and we get that MB plus 8 equals to 4MB. We subtract MB from this equation and we get that 8 equals to 4MB minus MB is 3MB. We divide this equation by 3 and finally we get that MB equals to 8 over 3 units. So, line segment MB, this line segment MB, it is equal to 8 over 3 units in its length. In the next step, we implement the Pythagoras theorem on the right triangle A and B. By PT is evaluation for Pythagoras theorem. According to the Pythagoras theorem, in any right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. So in the right triangle A and B, it means that AM square equals to AB square plus MB square. So I write it down, AM square equals to AB square plus MB square. Repeat again, in the right triangle A and B, according to the Pythagoras theorem, AM square equals to AB square plus MB square. So actually, AM square equals to AB square. AB is 2, so AB square is 2 square, that is 4, plus MB square. MB is 8 over 3, therefore MB square is 8 over 3 square. So AM square equals to 4 plus 8 over 3 square is 8 square, that is 64 over 3 square, that is 9. Here we multiply 4 by 9 and then we will divide it by 9 in order to have a common factor of 64 over 9. And we get that AM square equals to 4 times 9 is 36, so in total we have 36 plus 64 over 9. 36 plus 64, it is 100 over 9. We take a root out of this equation and we get that AM equals to the square root of 100 over 9. The square root of 100 over 9 is actually equals to the square root of 100, that is 10, over the square root of 9, that is 3. So in total we found out that AM equals to 10 over 3 units. We can write down in the original drawing that the hypotenuse AM equals to 10 over 3 units in its length. In the next step, I will present to you rule number 1 and we will implement the rule in our drawing. According to rule number 1, tangent to a circle is perpendicular to the radius drawn to its point of tendency. Here we have tangent AB that is tangent to this circle at point M, and the radius OM is drawn to point M, that is the point of tendency. Therefore, whenever we have a radius that is drawn to the point of tendency, then tangent AB will be perpendicular to the radius MO. So if AB is perpendicular to MO, it means that this angle equals to 90 degrees, and this angle also equals to 90 degrees. We can implement rule number 1 in our drawing. We define the center of this circle as O. Line segment AB is tangent to this circle at this point. We define the point of tendency as M. we join points O and them together by a straight line. Point O is the center of the circle. Point M is the point of the circle itself, therefore OM is the radius of the circle. We'll define the radius of the circle as x, so OM equals to x. The radius OM is known to point M. It is the point of tendency of tangent AB with the circle, and whenever you have a radius that is known to the point of tendency, then tangent AB will be perpendicular to the radius MO. If AB is perpendicular to MO, it means that this angle equals to 90 degrees and this angle equals to 90 degrees according to rule number 1. We define the point of tendency of tangent BC with this circle as N. We join points O and N together by a straight line. ON is the radius of the circle that is equal to x. The radius ON is on to point N, that is the point of tendency, therefore tangent BC will be perpendicular to the radius NO. That is to say, this angle equals to 90 degrees and this angle also equals to 90 degrees according to rule number 1. In quadrilateral MOBN, we have 2 free right angles. The sum of free right angles is 90 times 3 is 270 degrees. Plus the missing angle here. This is the missing angle. In total, the sum of those 4 angles must be equal to 360 degrees according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. Therefore, the missing angle here must be equal to 90 degrees. I repeat again, in order to complete the sum of the angles in this quadrilateral to 360 degrees, the missing angle here must be equal to 90 degrees. Okay, in the next step, we will draw perpendicular on BC in such a way that it will be also tangent to the circle. So this angle equals to 90 degrees and this angle equals to 90 degrees according to our construction. We define the touching point of the perpendicular on BC as M. We define the point of tendency of the perpendicular with the circle as edge. We extend the perpendicular M edge until it touches side DN of the triangle. We define the touching point between the perpendicular and side DN as point G. So GM, line segment GM, this line segment is tangent to the circle at point H. Point S is the point of tendency. We join points O and H together by a straight line. OH is the radius of the circle that is equal to x. The radius OH is known to point H, that is the point of tendency of tangent GM with the circle. Whenever you have a radius that is drawn to the point of tendency, then tangent GM will be perpendicular to the radius HO. So if GM is perpendicular to HO, it means that this angle equals to 90 degrees, and this angle equals to 90 degrees according to rule number 1. And for the other OH and M, we have 1, 2, 3 right angles. Therefore, the fourth angle must be equal to 90 degrees. According to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. Okay. Now, angle MOH, this angle, is equal to 90 degrees plus 90 degrees. It is 180 degrees. Again, angle MOH equals to 180 degrees in its size. And we know that any angle that is equal to 180 degrees, it must be a straight line. Therefore, angle MOH is a straight line. But angle MOH touches the circle at points M and H. Therefore, angle MOH, actually, MOH first of all is a straight line. If MOH is a straight line, then MH also must be a straight line. And the straight line MH touches the circle at points M and H. Therefore, therefore the straight line MH is a chord that passes for the center of the circle. That is to say, MH passes for point O, that is the center of the circle. And we know that any chord that passes through the center of the circle must be the diameter of the circle. Therefore, MH is the diameter of the circle. So I can write down here that MH is the diameter of the circle. In the next step, we will focus on quadrilateral MHBM. Inside quadrilateral MHBM, we have 1, 2, 3, 4 right angles. Any quadrilateral that has 4 right angles must be at least a rectangle, if not a square. So we relate to quadrilateral MH. We relate to quadrilateral MHBM as a rectangle. Here, actually I accidentally defined those two different points with the same letter. So I will define the point of the touching point of the perpendicular with BC instead of the letter M. I will define it as point S. Okay. So inside quadrilateral MHBS, we have 1, 2, 3, 4 right angles. Any quadrilateral that has 4 right angles must be at least a rectangle, if not a square. So we relate to quadrilateral MHSB as a rectangle, and we know that the opposite sides of a rectangle are equal to each other. That is to say, BS equals to MH. Okay. In rectangle MHBS, BS equals to MH. We can find here that MH equals to BS, and from this equation, BS equals to MH equals to the diameter, we will derive that BS is also the diameter of the circle. The diameter of any circle is twice as long as the radius. The radius of this circle is equal to x according to our definition. Therefore, the diameter BS must be equal to 2x. We found out that the length of line segment BS is 2x. In the next step, we'll focus on the right big triangle MGS. The right big triangle MGS, this angle equals to theta, this angle equals to 90 degrees, therefore the missing angle must be equal to 90 degrees minus theta. In the next step, we'll prove that the big right triangle MGS is similar to the small right triangle MAB. What is known, the big triangle MGS is similar to the right triangle A and B. So, why those two right triangles are similar to each other? First of all, those two angles are both equal to 90 degrees, therefore they are equal to each other. So you can write down angle GSM in the big triangle is equal to this angle, that is actually angle ABM in the small triangle. Repeat again. Angle GSM in the big triangle is equal to angle ABM in the small triangle. They are both equal to 90 degrees, therefore they are equal to each other. In addition, this is angle theta. It is a common angle that belongs to both triangles, so we can write down that angle theta equals to itself. Angle theta can be defined as angle GMS, and is equal to angle theta itself. We can define angle theta also as angle A and B. Again. This equation means that angle theta equals to itself. We just call to angle theta two different names. Why? Because angle theta it is a common angle that belongs to both triangles. And finally, those two angles are both equal to 90 degrees minus theta, therefore they are equal to each other. So angle MGS in the big triangle is equal to this angle that is actually angle MAS. No, it is angle MAB. This angle is angle MAB. In the small triangle, repeat again, angle MGS in the big triangle is equal to angle MAB in the small triangle. They are both equal to 90 degrees minus theta, therefore they are equal to each other. We actually proved that all the triangles in the big triangle MGS are correspondingly equal to all the triangles in the small triangle A and B. Therefore we proved that The two right triangles are similar to each other according to angle similarity rule. I write it down. So the big triangle MGS is similar to the small triangle A and B according to angle similarity rule. And from the fact that the two right triangles are similar to each other, we derive that the following relationship exists between their sides. We derive that MS is the big triangle over MB the small triangle is equal to GS in the big triangle over AB in the small triangle. Repeat again, we derive that MS over MB equals to GS over AB. What is the length of side MS? From the drawing it is very easy to see that MS equals to MB plus BS, that is to say MS equals to MB that is 8 over 3 plus BS that is 2x. So in total MS equals to 8 over 3 plus 2x. Over MB is 8 over 3 is equal to GS. GS is unknown, so we leave it as it is. Over AB. AB is 2, so we substitute AB by 2. So we found out that 8 over 3 plus 2x over 8 over 3 equals to GS over 2. Here we multiply 2x by 3 and then we will divide it by 3 in order to have a common factor with 8 over 3. So in the numerator of this side of the equation we have 8 plus 2x times 3 is 6x over 3 over 8 over 3 is equal to GS over 2. So here we have 3 in the numerator and 3 in the denominator, so 3 will get cancelled. And we left only with 8 with plus 6x over 8 equals to GS over 2. Here we cross multiply this equation and we will get that two times 8 plus 6x equals to 8 times GS. Two times 8 plus 6x equals to 8 times GS. Here we'll divide this equation by 2. And we get that 8 plus 6x equals to 8 over 2 is 4, so in total this expression equals to 4GS. Here we'll divide this equation by 4 and finally we'll get that the length of GS is 8 over 2 is 4 and plus 6x over 4, 8 over 4 is 2, and 6x over 4 is 1.5x. In total, we found out that ds equals to 2 plus 1.5x. The length of this 97 S0 ds is equal to 2 plus 1.5x. So the big triangle GMS is similar to the small triangle AMB, therefore addition relationship exists between their sides. The following relationship exists between their sides. MS in the big triangle over MB in the small triangle is equal to GM in the big triangle or AM in the small triangle. Repeat again. MS over MB equals to GM over AM. I've already explained to you that MS equals to 8 over 3 plus 2x. MB is 8 over 3. And it is equal to GM. What is the length of the hypotenuse GM? GM, from the drawing it is very easy to see that GM equals to GA plus AM. That is to say GM equals to GA plus AM, that is 10 over 3. In total, GM equals to GA plus 10 over 3. Over AM is 10 over 3. So here we multiply 2x by 3 and then we divide it by 3, and here also we multiply GA by 3 and then we divide it by 3. And then we get that this side of the equation in the numerator we have 8 plus 2x times 3 is 6x over 3 over 8 over 3 is equal to 3 times GA is 3GA plus 10 over 3 over 10 over 3. Okay. So here we have in this side of the equation 3 in the numerator, 3 and 3 in the denominator, so 3 will get cancelled. Here also we have 3 in the numerator and 3 in the denominator, so 3 here also will get cancelled, and we left only in this side of the equation with 8 plus 6x over 8 is equal to 3GA plus 10 over 10. Here we first multiply this equation and we get that 10 times 8 plus 6x equals to 8 times 3GA plus 10. We'll open the brackets on both sides of the equation and we get that 8 times 10 is 80 Plus 8 times 6x is 60x. Is equal to 8 times 3ga is 24ga. Plus 8 times 10 is 80. So here we have 80 on both sides of the equation, so 80 will get cancelled, and we left only if 60x is equal to 24ga. So here we divide this equation by 24, and we will get that ga equals to 60x over 24, it is equal to 2.5x. So here the length of this nice circle GA is equal to 2.5x. GA and G is equal to 2.5x. In the next step, I will copy quadrilateral ABSG here in the new page. Okay, this is quadrilateral AGBS, is the code from the original drawing. This quadrilateral blocks a circle. This is the circle that the quadrilateral blocks, so I'll copy the circle to the new drawing. The circle touches the quadrilateral at 4 different points. 1, 2, 3, 4. That is to say, the quadrilateral and the circle have 4 points of tangency between them. We define the first point of tangency as M, the second point of tangency between the quadrilateral and the circle is N, the third point of tangency is N, and the fourth point of tangency is C. In the next step, I present to you rule number 2, and you implement rule number 2 in our drawing. According to rule number 2, the lengths of two tangents from common standpoint to a circle are equal. We have the common standpoint point P. From the common standpoint point P, we have two tangents to the circle, tangent PA and tangent PB. And according to this rule number 2, whenever you draw from a common standpoint two tangents to a circle, then the length of those two tangents will be equal to each other. In this case, PA equals to PB. You can implement rule number 2 in our drawing. Then focus on the common start point, point A. From the common start point, point A, we have two tangents to this circle, tangent AM and tangent AN. According to rule number 2, they are equal to each other. That is to say, AM equals to AN. So if we define the length of tangent AM as A, then AN also equals to A because they are equal to each other. In the next step, we focus on the common start point, point B. From the common start point, point B, we have two tangents to the circle, tangent BN and tangent BN, and according to rule number 2, they are equal to each other. That is to say, BN equals to BL. If we define the length of BN as B, then BL must be also equal to B. We focus on the common start point, point S. From the common start point, point S, we have two tangents to this circle, tangent SN and tangent ST, and according to rule number 2, they are equal to each other. That is to say, SL equals to ST. If we define the length of SL as C, and the length of ST must be also equal to C. And finally, we will focus on the common start point, point G. For the common start point, point G, we have two tangents to this circle, tangent GM and tangent GT, and according to rule number 2, they are equal to each other. That is to say, GM equals to GT. So if we define the length of tangent GM as D, then GT must be also equal to D. In the next step, we'll join side AG to the opposite side BS. Let's call the other AG BS. Okay, so we join side AG to the opposite side, side BS. What is the length of AG? From the drawing, it is very easy to see that AG equals to A plus D. So substitute AG by A plus D in the equation. What is the length of VS? For the drawing, it is very easy to see that VS equals to B plus C. So in conclusion, we found out that AG plus BS equals to A plus D plus B plus C. We can change the orders of the letters here. Instead of A plus D plus B plus C, we can write down that this expression equals to A plus B plus C plus D In the next step, we will add side AB to the opposite side, side GS. The length of side AB is A plus B, so we substitute AB by A plus B. And the length of side GS is equal to C plus D. So in total, we found out that AB plus GS equals to A plus B plus C plus D, exactly as this expression. AG plus BS also equals to A plus B plus C plus D. So those two expressions, they are both equal to A plus B plus C plus D, therefore they are equal to each other. That is to say AG plus BS is equal to AB plus AG plus BS equals to AG plus BS equals to AB plus GS. Those two expressions are equal to each other. What is the length of line segment AG? The boy can clearly see that AG equals to 2.5x, so we substitute AG in the equation by 2.5x. What is the length of line segment BS? Is already to see that BS equals to 2x, so we substitute BS by 2x in the equation, and it is equal to AB. AB is 2, so we substitute AB by 2 plus GS. We already found out that GS equals to 2 plus 1.5x. Substitute GS by 2 plus 1.5x. In conclusion, we found out that 2.5x plus 2x equals to 2 plus 2 plus 1.5x. So 2.5x plus 2x is equal to 4.5x, and it is equals to 2 plus 2 is 4 plus 1.5x. Here we subtract from this equation 1.5x, and we get that 4.5x minus 1.5x is 3x. It is equals to 4. We divide this equation by 3, and finally we get that x equals to 4 over 3 units. That is to say the hypotenuse x of this circle is equals to 4 over 3 units. Our mission is to find out the area of this circle. Here the square bracket is the sum for the area. The area of any circle is equals to pi times the radius squared. If the radius is r, then it is pi r squared. Now, a specific circle, the radius is x, so it is pi x squared. We just right now found out that x equals to 4 over 3, so we substitute x in this equation by 4 over 3, and we get that the area equals to pi times x squared. X is 4 over 3, therefore x squared is 4 over 3 squared. So the area of the circle equals to pi times 4 over 3 squared. 4 over 3 squared equals to 4 squared, that is 16. over 3 squared, it is 9. So in conclusion, we found out that the area of this circle, it is equals to either 16 pi over 9 square units, or in terms of numbers, it is equals to 5.585 square units. Okay. So in the next step, I will summarize the lecture. So in the drawing we have quadrilateral ABCD. Inside this quadrilateral we have this circle. Know that line segment AB equals to 2 units, line segment BC equals to 8 units, line segment CD equals to 8 units also. This angle ABC equals to 90 degrees, this angle DCP also equals to 90 degrees. Our mission is to find out the area of this circle. So first of all, we did the construction. We extended side DA and side CB of the quadrilateral until they touch each other. So, yeah, we extended side DA and side CB until they touch each other. At this point, we define the touching point as M. So here we have CB is one side of quadrilateral ABCD, therefore it is absolutely a straight line. When we extended the straight line CB by straight line, the result is CM. When we extend the straight line by straight line, the result must be a straight line, so CM must be also a straight line. If you focus on the upper side of the straight line CM at point B, here the sum of the angles must be equal to 180 degrees according to the rule that the sum of the angles on one side of a straight line is equal to 180 degrees. So which angles we have at the upper side of CM at point B? We have this angle that is equal to 90 degrees plus the missing angle ABM. In total they must be equal to 180 degrees according to the rule that I mentioned. Therefore the missing angle here must be equal to 90 degrees. And again, in order to complete the sum of the angles on the upper side of CM at point B to 180 degrees, the missing angle ABM must be equal to 90 degrees. So in the right triangle ABM, we define this angle as theta. So this angle equals to theta, this angle equals to 90 degrees. Therefore, the missing angle must be equal to 90 degrees minus theta. Why? Because 90 degrees minus theta plus theta, it is 90 degrees, and 90 degrees plus 90 degrees, it is equals to 180 degrees. That is the sum of the angles in any triangle. Okay. Likewise, in the big right triangle DCM, this angle equals to theta, this angle equals to 90 degrees, therefore the missing angle must be equal to 90 degrees minus theta. Then we prove that the big triangle MDC, the big right triangle MDC, is similar to the small triangle ABM. So why those two triangles are similar to each other? First of all, those two angles are both equal to 90 degrees, therefore they are equal to each other. In addition, this is angle theta, it is a common angle that belongs to both triangles, so angle theta equals to itself. And finally, those two angles are both equal to 90 degrees minus theta, therefore they are equal to each other. So we actually proved that all the three angles in the big triangle DCM are correspondingly equal to all the three angles in the small triangle ABM. Therefore, those two right triangles are similar to each other according to angle similarity rule. Okay, and from the fact that the two right angles are similar to each other, we derive that the following relationship exists between their sides. We derive that MC, the big triangle, over MB, the small triangle, equals to DC, the big triangle, over AB, the small triangle. Repeat again. MC over MB equals to CD over AB. From the drawing, it is very easy to see that MC equals to MB plus BC, that is to say MC equals to MB plus BC, that is 8, so in total MC equals to MB plus 8. So we substitute MC by MB plus 8 over MB, that equals to CD, that is 8, over AB, that is 2. So CD over AB, it is 8 over 2, 8 over 2 is 4, 4 equals to MB plus 8 over MB. We multiplied this equation by MB and found out that 4 times MB equals to MB plus 8. We subtracted MB from this equation and found out that 8 equals to 4MB minus MB, it is 3MB. So 8 equals to 3MB, we divided this equation by 3 and found out that MB equals to 8 over 3 units. This line segment MB equals to 4 over 3 units. Then we implemented the Pythagoras theorem in the right triangle ABM. According to the Pythagoras theorem, AM square equals to AB square plus BM square. Repeat again. AM square equals to AB square plus MB square. So AM square equals to AB square, AB is 2, therefore AB square is 2 squared, that is 4, plus MB square, MB is 8 over 3, therefore MB square is 8 over 3 square. So AM square equals to 4 plus 8 over 3 square. 8 over 3 square is 8 squared, that is 64, over 3 squared, that is 9. Then we multiplied 4 by 9 and then we divided by 9 in order to have a common factor with 64 over 9. And we found out that AM square equals to 4 times 9 is 36, so in the numerator in total we have 36 plus 64 over 9. 36 plus 64, it is 100 over 9. We took out of this equation and finally found out that AM equals to the square root of 100 over 9. The square root of 100 is 10 and the square root of 9 is 3. So in total we found out that AM equals to 10 over 3 units in its length. AM equals to 10 over 3 units in its length. Then I presented to you rule number 1 and we implemented rule number 1 in our drawing. Coming to rule number 1. A tangent to a circle is perpendicular to the radius drawn to its point of tendency. We have tangent AB, that is tangent to this circle is point M, and the radius OM is drawn to point M, that is the point of tendency of tangent AB with this circle. Whenever you have a radius that is drawn to the point of tendency, then tangent AB will be perpendicular to OM, so if to the radius OM. If AB is perpendicular to OM, it is that this angle equals to 90 degrees and this angle equals to 90 degrees according to rule number 1. This is rule number 1. So we implemented rule number 1 in our drawing. We define the center of this circle, this point as O. We define the point of tendency of tangent AB with this circle as M. We join points O and M together by a straight line. Point O is the center of the circle, point M is the point of the circle itself. Therefore, OM is the radius of the circle that we define as X. The radius OM is drawn to point M, that is the point of tendency of tangent AB with this circle. Whenever you have a radius that is drawn to the point of tendency, then tangent AB will be perpendicular to the radius MO. If AB is perpendicular to MO, it means that this angle equals to 90 degrees and this angle equals to 90 degrees according to rule number 1. BS is tangent to the circle at this point. We define the point of tendency as N. We join points O and N together by a straight line. ON is the radius of the circle, that is X. The radius ON is drawn to point N, that is the point of tendency of tangent BS with this circle. And whenever you have a radius that is drawn to the point of tendency, then tangent BS will be perpendicular to the radius NO. If BS is perpendicular to NO, it means that this angle equals to 90 degrees and this angle equals to 90 degrees according to rule number 1. So inside quadrilateral MOBN we have 1, 2, 3 right angles. the sum of three right angles 90 times 3 is 270 degrees plus the missing angle. In total, they must be equal to 360 degrees. According to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. Therefore, the missing angle here must be equal to 90 degrees. 270 degrees plus 90 degrees is 360 degrees. That is the sum of the angles in any quadrilateral. Then we draw perpendicular on BS in such a way that it will be also tangent to the circle at point H. So this angle equals to 90 degrees and this angle equals to 90 degrees according to our construction. We extended the perpendicular SH until it touches side DM at point G. So tangent GS is tangent to the circle at point H. We join points O and H. We join points O and H together by side line. OH is the radius of the circle that is equal to X. The radius OH is drawn to point H, that is the point of tendency of tangent DS with this circle. Whenever you have a radius that is drawn to the point of tendency, then tangent GS will be perpendicular to the radius HO. If GS is perpendicular to HO, it means that this angle equals to 90 degrees and this angle equals to 90 degrees according to rule number 1. So in quadrilateral OHSN we have 1, 2, 3 right angles. Therefore the fourth angle must be equal to 90 degrees according to the rule that I already mentioned, that the sum of the angles in any quadrilateral is equal to 360 degrees. Okay, so here angle MOS, this angle is equal to 90 degrees plus 90 degrees, it is equal to 180 degrees. Again, angle MOS equals to angle MOH, this angle equals to 180 degrees. Any angle that is equal to 180 degrees, it is a straight line. Therefore, MOH is a straight line. If MOH is a straight line, then MH must be also equal to If MOH is a straight line, then MH is also a straight line. The straight line MH touches the circle at points M and H. Therefore, MH is a chord that passes through point O, that is the center of the circle. Any chord that passes through the center of the circle must be the diameter of the circle. Therefore, MH is the diameter of the circle. MH is the diameter of the circle. Then we focused on quadrilateral MHBS. Inside quadrilateral MHBS we have 1, 2, 3, 4 right angles. Any quadrilateral that has 4 right angles must be at least a rectangle if not a square. So we relate to quadrilateral MPSH as a rectangle. And we know that the opposite sides of a rectangle are equal to each other. That is to say, MH must be equal to BS in rectangle MHBS. MH equals to BS. So we can argue that MH equals to BS. And from this equation, BS equals to MH equals to the diameter, we will derive that BS is also the diameter of the circle. And we know that the diameter of any circle is twice as long as the radius. And the radius is x, therefore the diameter BS must be equal to 2x. So here, BS equals to 2x. Then we focused on triangle GSM. In triangle GSM, this angle equals to theta, this angle equals to 90 degrees, therefore the missing angle must be equal to 90 degrees minus theta, as I already explained before. Then we proved that the big triangle MGS is similar to the small triangle ABM. Why those two triangles are similar to each other? First of all, those two angles are both equal to 90 degrees, therefore they are equal to each other. In addition, this is angle theta, it is a common angle that belongs to both triangles, so angle theta equals to itself. And finally, those two angles are both equal to 90 degrees minus theta, therefore they are equal to each other. So we actually prove that all the three angles of the big triangle GSM are correspondingly equal to all the three angles of the a small right triangle ABM. Therefore, the two right triangles are similar to each other according to angle similarity rule. And from the fact that they are similar to each other, we derive that the following relationship exists between their sides. That MS over MB, MS in the big triangle over MB in the small triangle, is equal to GS in the big triangle over AB in the small triangle. I'll repeat again. MS over MB equals to GS over AB. From the drawing, it is very easy to see that MS equals to MB plus BS. That is to say, MS equals to MB, that is 8 over 3, plus BS, that is 2x. In total, MS equals to 8 over 3 plus 2x. Repeat again. MS equals to 8 over 3 plus 2x. MB equals to 8 over 3. GS is unknown, so we leave it as it is, and AB equals to 2. Then we multiplied 2x by 3, and then we divided by 3 in order to have a common factor with 8 over 3. So here we have in the numerator 8 plus 2x times 3 is 6x. So in the numerator here we have in total 8 plus 6x over 3 over 8 over 3, that is equal to GS over 2. We have 3 in the numerator and 3 in the denominator, so 3 will get cancelled, and we left only with 8 plus 6x over 8, that is equals to GS over 2. We cross multiply this equation. We found out that 2 times 8 plus 6x equals to 8GS. Repeat again. Two times 8 plus 6x equals to 8GS. We divided the equation by 2 and found out that 8 plus 6x is equals to 8 over 2 is 4, so in total this expression equals to 4GS. Then we divided this equation by 4 and found out that GS, the length of line segment GS, it is equals to 8 over 4 is 2, and 6x over 4 is 1.5x. So in total, the length of GS is equals to 2 plus 1.5x. GS equals to 2 plus 1.5x. Then, because of the fact that the big triangle GSM is similar to the small triangle ABM, addition relationship exists between their sides. The following relationships exist between their sides. MS in the big triangle over MB in the small triangle equals to GM in the big triangle over AM in the small triangle. Repeat again. MS over MB equals to GS over MA. I've already explained to you that MS equals to 8 over 3 plus 2x. MB is 8 over 3. What is the length of GM? From the drawing it is very easy to see that GM equals to GA plus AM. That is to say GM equals to GM equals to GA plus AM, that is 10 over 3. So in total, GM equals to GA plus 10 over 3. So here, GM equals to GA plus 10 over 3, and MA it is equals to 10 over 3. Then we multiplied 2x by 3 here, and then we divided by 3. And then we multiplied GA by 3, and then we divided it by 3. And we found out that in the numerator we have 8 plus 2x times 3 is 6x. So in total we have in the numerator 8 plus 6x over 3 over 8 over 3. Here multiply GA by 3, so it is 3GA plus 10 over 3 over 10 over 3. Here we have 3 in the numerator and 3 in the denominator, so 3 will get cancelled. So in this side of the equation we left only with 8 plus 6x over 8. Here we have 3 in the numerator and 3 in the denominator, so 3 will get cancelled. So in this side of the equation we left only with 3GA plus 10 over 10. Okay, so here of course multiply this equation and found out that 10 times 8 plus 6x equals to 8 times 3GA plus 10. We open the brackets on both sides of the equation and found out that 10 times 8 is 80 plus 10 times 6x is 60x, and that is equals to 8 times 3GA is 24GA, and 8 times 10 is 80. So we have 80 on both sides of the equation, so 80 will get cancelled. We left only with 60x, that is equal to 24GA. We divided this equation by 24 and finally found out that GA equals to 60x over 24, it is equal to 2.5x. Here, the length of this line segment GA, the length of this line segment GA, it is equals to 2.5x. Then I copied quadrilateral AGSB in a new page. This is quadrilateral AGBS that I copied from the original drawing. This quadrilateral blocks this circle, so I copied the circle in the next drawing here. The quadrilateral touches the circle at 4 points. 1, 2, 3, 4. Actually, in other words, the quadrilateral and the circle has between them 4 points of tangencies. Those M, T, L, and N. Okay? They are tangent to each other at 4 points. M, T, L, and N. Then I presented to you rule number 2 and we implemented rule number 2 in our drawing. According to rule number 2, the lengths of two tangents from common external point to a circle are equal. Point P is the common external point. From point P we draw two tangents to this circle, tangent PA and tangent PB. According to rule number 2, whenever you draw from a common external point two tangents to a circle, then the lengths of the two tangents must be equal to each other. In this case, PA equals to PB. We implemented rule number 2 in our drawing. In our drawing, we have the common external point, point A. From the common external point, point A, we have two tangents to this circle, tangent AN and tangent AM. And according to rule number 2, they are equal to each other. That is to say, AN equals to AM. So if we define the length of AM as A, then AN must be also equal to A. Then focus on the common external point, point P. From the common external point, point P, we have two tangents to this circle, tangent BL and tangent BN. And according to rule number 2, they must be equal to each other. That is to say, BN equals to BL. So if we define the length of BN as B, then BL must be also equal to B. Then we focus on the common external point, point S. From the common external point, point S, we have two tangents to this circle, tangent SL and tangent ST. And according to rule number 2, they must be equal to each other. That is to say, SL equals to ST. So if we define the length of SL as C, then ST must be also equal to C. Okay. And finally, focus on the common external point, point G. From the common external point, point G, we have two tangents to this circle, tangent GM and tangent GT. And according to rule number 2, they are equal to each other. That is to say, GM equals to GT. So if we define the length of GM as D, then the length of GT must be also equal to D. Then we added side AG to side BS in quadrilateral AGBS. AG plus BS. AG equals to A plus D. BS equals to B plus C. So in total, we found out that AG plus BS equals to A plus D plus B plus C. We can change the order of the letters here. Instead of A plus D plus B plus C, we can write down A plus B plus C plus D. Those expressions are equal to each other. We just change the orders of the letters. Then we added side AB to side GS in this quadrangle AGBS. AB equals to A plus B, GS equals to C plus D. So in total, AB plus GS equals to A plus B plus C plus D, exactly the same value of the expression AG plus BS. It is also equals to A plus B plus C plus D. And because of the fact that both of those two expressions, they are both equal to A plus B plus C plus D, we can conclude from it that they are equal to each other. That is to say, AG plus BS equals to AB plus GS. Okay. AG equals to 2.5x, therefore substitute AG by 2.5x plus BS. BS equals to 2x, so we substitute BS in the equation by 2x, and it is equals to AB. AB is 2, so substitute AB in the equation by 2, and finally plus GS. GS equals to 2 plus 1.5x, so we substitute GS in the equation by 2 plus 1.5x, and finally found out that AG plus BS that is equals to AB plus GS is actually equals to 2.5x plus 2x, that is equals to 2 plus 1.5x. 2.5x plus 2x is 4.5x, that is equals to 2 plus 2 is 4 plus 1.5x. We subtracted 1.5x from this equation and found out that 4.5x minus 1.5x, it is 3x, so this equation in total equals to 3x equals to 4. We divided this equation by 3 and found out that x equals to 4 over 3. That is to say, the radius of this circle x, it is equals to 4 over 3 units. So our mission is to find out the area of this circle. The area of any circle, the square bracket is the sign for the area. The area of any circle equals to pi times the radius square. If r is the radius, then it is pi r square. In our specific case, we define the radius of the circle as x, therefore it is pi x square. The area of our circle is pi x square. We just right now found out that x equals to 4 over 3, so I can substitute x by 4 over 3. Pi x squared is equals to pi, x is 4 over 3, therefore x squared is 4 over 3 squared. So in total, the area for a circle is equals to pi times 4 over 3 squared. Pi times 4 over 3 squared. 4 over 3 squared is equals to 4 squared, that is 16, over 3 squared, that is 9. So in total, the area of this circle equals to either 16 pi over 9 square units, or in terms of numbers, the area of the circle, it is equal to 5.585 square units. So repeat again, the area of this circle, it is equals to either 16 pi over 9 square units, or in terms of numbers, it is equals to 5.585 square units. Okay, thank you very much.